Hello, everyone. A warm welcome to each of you from the Enkidu training team. We are pleased to have you join us for today's webinar titled Restarting Oil Wells. My name is Mohammed and I'll be your host for this session. The webinar will be presented by our speaker, Mr. Mohammed Al-Jawhar. Mr. Mohammed Al-Jawhar is a senior petroleum engineer with substantial expertise in petroleum engineering, production management, and strategic planning. He is recognized for optimizing operations and advancing long-term efficiency and value. Possessing a deep understanding of engineering principles, production protocols, Mr. Al-Jawhar is also respected for his strong communication skills and ability to build effective relationships across teams and leadership levels. Before we begin, please take note of the following important points. Should you have any questions during the presentation, you are encouraged to submit them via the Q&A box. All questions will be addressed during the dedicated Q&A segment at the conclusion of the webinar. Kindly be advised that this session is being recorded. Throughout the presentation, we will provide relevant links in the chat box to Enkidu training platforms such as Udemy, LinkedIn, Facebook, WhatsApp, and YouTube. A link to the attendees registration form will be shared before the end of the session. Please note that the certificates of participation will be issued via the Enkidu page on the Udemy platform. At this time, I invite to join me in extending a warm welcome to Mr. Mohammed Al-Jawhar. Mr. Al-Jawhar, the floor is yours.
Thank you, Doctor, for your introduction, and thanks for the attendees to attend this webinar, and thanks for Enkidu Training for this opportunity to present our session today about starting oil wells. I hope we enjoyed this webinar through the material provided. So, before we start the session, this webinar, let me talk about a little bit about restarting oil wells. So, what it's mean restarting oil wells? What's this word restarting? So, why it's restarting? So, it's output prod. We know all of us we put the well after drilling on production, and that well is flowing for a long-term period with a certain flow. But sometimes there's wells going down in terms of performance, and then we found these wells seized. So why these wells seized? So restarting an oil well after cessation of production, we can briefly talk about it. It's a technically delicate and potentially high risk process. So it's not easy way to restart wells. We'll talk about it in a few minutes. So it's a high risk process that requires a structured and multidisciplinary approach. Why? We will know that. Why? The goal is to something we need a high, something we need to make it low. So what we need to make it high, we need to make sure the goal is to safely re-enter those wells on production again, evaluate and stop production from those seized wells. What we need to make it low or minimize is definitely the cost. Sometimes it need a higher cost to put those wells, those wells online again. So we definitely are looking at the cost of is it worth to put those wells online again or keep it as they are or change their situation to another status. So it depends on the our plans. So and then we need, of course, we need to minimize the environmental risks and downtime of these wells when it's seized. So we don't want to make it a long term of cessation because otherwise we're losing production from those wells. So it's not easy process. We need to look at some data before what data we need to look. So let's go through it. So what we will discuss today. Okay. So integrated asset modeling. What do we mean by integrated asset modeling? The operational plot, well monitoring and guidance, the basic problem of the production, successful oil well start. What's the key points to for oil restart, oil well starting? So we'll see in a minute. So let's start with this illustration, this beautiful illustration. What tell us and what we the key takeaways from this illustration. So you can see from this illustration we have some injection, we have producers. So those injectors providing the pressure enhancement for our reservoir, butyl reservoir, and then we have a good performance, let's say a stable production rate from this product produced well. So oil well, it's I mean the stable oil production rate from this oil producer. So if it's oil or gas anyhow, so let's consider it's oil, mixed liquid, any type of liquid. It's most probably oil. So we have this system of injectors and producer connected to the degassing station and to the export line. So what happened inside the reservoir? So we know, of course, inside our reservoir there is layers, and maybe those layers connected together. We have some perforation inside our wellbore, and water injection goes and enhance the production from those wells. Sometimes this integrated system, there is a problem in some place, and then we can see afterwards this production. I mean, if we have a production profile, so change the color. So we can see it's going down, 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 and then the well is seized. So why it's seized? There's a different reason behind. We need to search why the well is seized. What is the criteria of what is the key players in term of cessation? So we need to look at the data and history, matching everything else, our simulation, our reservoir properties, what's going on, why the well is not flowing again. So it's a complete picture. We cannot separate injectors if we have any type of injectors. It's the majority of the field is quite old, and there is a profile of water flooding, etc., gas, anything. So we need to look at what is the reservoir condition, where is our wells perforated, which intervals, which reservoir, what is the type of the reservoir, anything we need to collect before we say, oh, okay, why it's this well is seized. So let's have a look. So one of the things can be extracted from our production profile. It's degassing performance plot. Before going to our well, we can see from the degassing itself, because there is a performance for the degassing. What do you mean by degassing performance? Where some wells is connected to one degassing station, and we can see there is a lot of wells connected to that degassing, and some and part of it it's offline. So okay, this is what we need to know. Why those wells is offline? Do we put those wells offline because something happened in the degassing? So you can see from the plots from these trends, uh, it's going down in terms of the production rate. So why this happened? Is it normal? Do we do something, for instance, do we stop the production in the degassing because we're doing a tar? Do we have any problem in the degassing itself? So if term of we doing a tar, that's mean we have to put some wells offline, converting some wells, online wells from degassing to another. So if we consider, for instance, this is the degassing number one, and this is the degassing number two. So there is a certain production from one, let's say 10,000 barrel, okay, and we have 20,000 from for this degassing. So there's some wells connected to this degassing station, okay, and there's a flow line from those wells to this degassing, and another wells connected to another degassing station. So those wells, in terms of performance, giving around 20,000 barrel per day, and those wells giving us around 10,000 barrel per day. So if we consider we have maintenance, so we have to shut in those wells. So we have to consider, for instance, converting those wells from this degassing to this degassing. Let me change the color. We can just a minute. Okay. So if we consider changing the routes of the flow lines from this degassing to this degassing, so what will happen? So if we consider the distance between here and here, it's 2 kilometers, and from here to here, it's 4 kilometers. So we doubled the distance between this well, before it's two, now it's four. So one of the reasons there is a back pressure on this well. Okay, so the well is not performing well. So let's say it's less than 1 MBD per day, and because if we have putting more pressure on this well to flow to the gassing number two, then because we have a maintenance, so we need to do some maintenance on our degassing to remove tar or etc. There's damage in some parts, so we need to install a new lines, new tanks, anything we can. It's related to degassing itself, because it's we can say from time to time we have to do something. So what happened to our well? To our wells. It's converted from this part and with this distance, and then we double the distance. Then we have a back pressure because this degassing, it's high performance. Let's say it's 20. This one it is 10. Then we have putting those wells in a header where we have good performance wells. Let's say it's more than 2 MBD. Then we have a back pressure, not from the distance. For instance, it's more about the headers where the new wells is converted and connected. So there is another part of connect. We have a reason where our wells can not be flowing. So there's multiple types of and circumstances where we have some wells it's not flowing naturally in for the first place. So back again to our illustration, what we have here. we have like this period, and then we can see we putting our wells where the those wells back online with normal condition. But what would happen? We lose some wells. So back online, shut in, not back online. Why? We don't know. We need to investigate. We need to know what is the web performance before, what is happening, why when the tar is removed, when we put everything in normal condition. But what we can see from here, the trend is not going straight. There's a fluctuation in our trends. So there is no stable performance for some wells. What happened? For instance, we do not operate our wells perfectly, so maybe there is water coming through, water breakthrough, and this affecting the production. So this is not our case here today. We need to to consider what is happening to our wells, preventing them not going perfectly in terms of production. Why those wells struggling to be online again in normal condition? So we have to think about, okay, we have this trend, it's nice, beautiful here, but we have some struggling here going up or in term of be in stable condition as they before. So you can see it's more stable than this period. Why? Then we can see there is somewhere else it's not back online and still offline. Okay, let's go further with our investigation. So this is one of the illustration we can see from this illustration. We have most of the wells or all of the wells connected to the digital oil field. We can see the upstream pressure, downstream pressure, the line, choke, etc., temperature, everything is fine, but we have to check these parameters. Is it normal? Do we do have any double check in terms of what is the well is doing? Is it stable enough? So is there any highlight in somewhere because we have missing data? We have some problem in terms of there's a back pressure on the flow line. There is a back pressure here. The differential pressure between the downstream upstream, it's not quite enough to make the well it's flowing. Is the choke performance? It's not suggesting as we would like to. So what is the water cut? Is it raised or is it not? So there's a lot of questions we can ask ourselves if the well is not flowing perfectly or the well is going to be seized. And when the well is seized, we can understand we have some triggers from our system where we have some issue regarding the well performance. And if we back again, it's not for the wells, it's for the degassing. So we understand some wells is not back online because when we put all the wells online, some of it it's flowing, some of it is not. And if we back again to check our system, there's a calculation behind, and these calculations tell us, okay, there's a zero flowing. So all the wells is not flowing perfectly. Okay, let's check now for our wells. What is happening? Why those wells is now not going back again? So data review and history matching is essential part to for our well files. We need to check the production history, reservoir performance, well integrity, to what? To identify the reason for cessation. Is there any water breakthrough, gas breakthrough? Is there any sound or mechanical failure? Do we have any formation damage? Do we do any shut-in because of some regarding economic factors? So let's have a look on this operation plot where we have water cut, so it's almost stable. What we have here, the red is tubing temperature, the green is annulus if, through the well is flowing through the annulus. Before was tubing annulus. So we can see there's a change in situation. Okay, maybe this what we have here. So it's choked back here. The well is choked back and opened gradually. Why? Because the data suggests we need to choke back well because here you can see the well it's not flowing perfectly. Maybe it's related to the tar when we have tar and then it's open again. Is it stable enough? We can see the temperature pressure for the upstream and downstream just not like before. It's now it's September. This is in March and April, so it's going down and going down. Maybe that's can be indication of we have a raising of water cut. We changed. That's why we changed from tubic annulus to annulus. The temperature is not performing well, so that tell us there's no enough flow from this well. So many questions regarding this plot, and this nice plot from OFM telling us, okay, check your well performance. You need to see why it's struggling and there's differential pressure between the upstream and downstream just very close. Is it normal or not? Because if we go back in 1 month, around more than 100 psi. Now it's around 10. Do we do any optimization? And that optimization is not going well. So it's not the good optimization we did for that well. And you can see there's a lot of playing with the flow path from annulus to tubing annulus, back annulus, back in tubing annulus. The choke is changed in the very short time from one set to another set. Is that affecting the well performance? Because we need to have a look on the well history. So what we have as a key takeaway from this plot, it's the integration of the historical data we have from our reservoir performance, from our degassing performance, from our well performance, and we can compare it with our simulation and what it tell us regarding what is the well is doing. So the well and the end of the day is seized and we need to know we need to know why we need to know why the well is seized. Is it because all these changes happened in a very short time? Is there any intervention done for this well to put it online? Maybe there is cessation before the well was stable and maybe here we have some issue and here we have another issue, then it's put online again with more potential. So there is a potential from changing the chalk from this set to this set. So we are trying to open up the well because we think we are choking the well. Maybe the well has a potential. The raising of water cut, maybe that there's the well is loading, then we need to know is that will be a more suitable option for our well. And unfortunately, we're losing this well afterwards, and it's now offline maybe. Okay, let's go through the other slides. So let's have a look in whole picture. So what we have a degassing and those wells it's connected to those degassing. So X1 to X4 connected to degassing A, X5 to X8 connected to degassing B. The reservoir layers is suggested here. So what is the daily production? 2.3, 4 MBD, zero point 0.6. Okay, so this is zero point 0.6. 5.6, good well. Zero point 0.9, 10 MBD, very good well. 3.2, 1.7. Okay, so is it connected to the high or low pressure feeder? What is the well status? Is it running through by ASP or natural reflow? So, okay, we have, you can see it's ESP, the production source. Is it tubing annulus, tubing only, annulus only? So, is it running through ESP? What is the train connected? And where in the pressure data? So, if we go back, we can see there is, it's like multiple readings, it's nice readings. It's not in a minute. I mean, maybe it's not a real data, but it's more frequent data we have, so we can check the well in terms of pressures, temperature, etc. And then it's the pressure data. Is it very old or it's new? So what is the choke performance? Then we can see the pressures which tell us, okay, is this pressures related to the is this pressure related to for the well? Is it good or enough? I mean, the upstream pressure, the downstream pressure. What is the water cut reading afterwards? Is it too high, too low? Is it quite recent or very old? Do we need to do any relevant new readings for to confirm what is the reading? So if we go back again to compare uh, the water cut readings, you can see if we suspect any water cut readings, then we can go back and check for a new reading. So if you can see one happened in mid of April, early June, another in late August. So it's quite long. Maybe there's a reading here in end of July. So it's a quite long period when we have some readings. So is the situation now is the water cut is raised and that water cut rising in our column inside the wellbore, causing this well is going offline. So many cases it's different from well to well. Where is it? Which layer is from producing from? Where is it connected to which header? Is it high pressure, low pressure? What is the well performance? And what is the water cut? So, for instance, this 54 is high water cut value for this well. It's flowing through tubing only. Is that the tubing source, production source? Is it good for that well? This is well. This well is naturally flowed and low pressure with zero point 0.6. So we can consider this historical data as a key question: is the well worth reactivating based on economic and technical parameters we have before, and if it's seized? And okay, this well may be seized, and we can check why it's seized when we comparing the data before and now. So where the well monitoring awareness is very important because we need to establish a records for each well. So for instance, what does the guidance tell us? For X1, if we have an example, so review temperature, tubing annulus flow set to tubing only. Okay, so the recommendation is changing from tubing annulus to tubing and take readings in this date. So another partial closed gate valve causing delta P. So why it's highlighted here? So that you can see and you can read the notes, but sometimes we have to monitor closely why it's the well is not fluctuating. There is a partial closed gate valve. Okay, we don't know the main reason for the well is not performing. There is a partial closed gate valve, so it's not changing our production flow path from tubing to tubing only, tubing annulus, I mean, to tubing only. It's the simulation not telling us, the model not telling us because it's just changing the from this flow path, but because we didn't notice in the field the gate valve is partially closed. Another example, continue to monitor flow. Why? Because we check this well, the flow is not stable. So continue to monitor flow. This is another indication of why it's the well may be seized. Monitor well when tubing temperature drops below this number, close tubing flow. Set choke to this set number, desired data pressure, it's 50 psi across the choke. Investigate cause of higher back pressure. Okay, again, why it's high back pressure? Do we convert the well because we have a term and maintenance and our degassing, so the well is not flowing enough, and then where the well is seized. So investigate cause of higher back pressure. So many you can see for each well we have a relevant data and we have a guidance to monitor why those wells selected because we double checked those wells and we saw according to our data it's not flowing enough and there is a possibility to losing those wells, so maybe it's will be short. So for instance, if we check confirming flow and report to the management, shut in for pressure buildup. So maybe there is a certain survey going on for that well, and then we have the well is seized because it's not going back because after the survey it's not fairly enough to for this well because it's not flowing enough and it's low rate flowing well, so it's not recommended for instance to make like these surveillance data, conducting surveillance data from like those wells because it's choked back and then we can lose those wells. So it depends what is the monitoring and guidance for the wells. It depends on what is the history we have. So if we have, we need to investigate for this reason. So we need to check the well history and again we need to check the well integrity and safety inspection because it's mandatory before any intervention. So sometimes we have some issues regarding that, and we have some issues regarding the annular or tubing pressure. We need to perform that test before doing any surveillance. We can do leak detection on and corrosion check. Uh, we need to investigate if we have any something related to the well integrity before doing any surveillance. So it's not we're not talking about the surveillance, but we're talking about why is it checked the well performance before we doing any surveillance for any wells before moving forward, and then we have lost those wells because we didn't consider these factors. Okay, let's move forward. The basic problem of production. So looking at this illustration, what we can found the main reservoir pressure 4,000 psi, the PWF inside our well, it's this number, the upstream, downstream separator pressure, these numbers. It's nice illustration. The well, it's look like there's no problem. The well is flowing and there's nothing, any issue regarding the well flowing to the surface. So getting flows from reservoir to the separator, what we have, what we need, it's from reservoir to the separator. Uh, from reservoir to bottom of well bore drawdown. So we have drawdown here 4,000, 3,100, 600. So we have drawdown. It's sufficient to remove, lift the liquid to the surface. From bottom of the wellbore to the wellhead, okay, we have 300 here, 3,600. It's enough to lift the column to the surface, cross the choke, from choke, cross flow line to finally to the separator. So it's nice illustration showing the well is flowing without any problem. So where's the problem? Okay, there's two parts. Problems we create and problems from the reservoir itself. So completion design, it depends on our completion design. It's very important to have the right completion for our wells. Otherwise, we have not considering the right calculation for the flowing, for the what is the desired flow rate for that well? Is it naturally flowing? Is it by any another type of enhancement of production like electrical submersible, sub sucker rod, etc. What is the choke of? Is it fully opened? It's half opened. Why? What is the design of the choke? What, do we do any calculation for the check choke performance before installing that choke? Is this the right size of the choke to that flowing well? Flow line dimension. So we consider like this illustration. We showing that for instance, we have this well, and this well is connected to the degassing station. It's from this point to this point, but maybe it's not flowing like this. It's maybe goes with inclination going down, and then maybe reach to the destination. So it's now another type of flow line dimension. Is it 6 inch, for instance? Is it a 8 inch flow line? So is it 4 inch flow line? What the type of the flow line dimension we installed, and do we consider the geographical area and from the well to the degassing itself when we connect to the header? So like this, it's be should be considered when we have any design for the putting any design for flow line dimension and length. Separator pressure. Okay, we saw from our previous illustration we have 150 psi. So is the differential pressure between the first stage separator and the downstream pressure is enough, because we need extra psi more than the first stage. Is it set enough delta psi between the downstream and the separator pressure to make the well flowing? So it's depending on the separator pressure design, setting pressure. So is it enough for our well to flow? So this is what we create. And from the reservoir pressure. So what is the reservoir pressure? What is the water cut reading right now? What is the oil chemistry PVT for the reservoir? Do we consider this as the cause of problem for the well is seized and not back online again? Why it's seized? Because we have a less reservoir pressure. We don't have any support. We have raised in water cut. So we didn't notice. We have like this example before seconds where we saw the readings not consistently coming up to our screen, so we cannot check is it relevant enough like these data. Do we need regular readings for the water cut? Do we have any water breakthrough we don't notice? So do we do any surveillance in hand, and that surveillance is sufficient to indicate where we have any intervals where we have water breakthrough and that's causing the well is loading and not flowing? The oil chemistry, of course, do we have any raised in GR, etc.? So what is the viscosity of our reservoir? So all the parameters for oil chemistry, it's which is related to the reservoir, is very important to notice. Otherwise, we're missing some part on these parts. It's uncovered. Then we have hidden area of why the well is seized. So what happened when a well is shut in? Let's see. When the well is shutting, before it's shutting, the well is flowing. There is a differential pressure between the reservoir pressure and the well bore pressure. And then when it's shut in, it's raised. So because we don't have any flow to the surface anymore. So we have like this raise in the pressure inside our reservoir because the well is not flowing, so there is no any flow from the reservoir to the wellbore inside the wellbore. I mean, okay. What happened when the well is shut in? Back again to the normal. So this is the initial filled with fluid. What happened afterwards when the wells shut in? There is a more gas. You know, because the pressure, the system is pressurized, so the gas is dissolved inside the fluid, inside the oil. So it's one system. Now we have two phase. So it's one phase here, and more gas performs inside our well bore. Okay. Then we can see if there is a water breakthrough of, or we have more water inside our wellbore, or we have a gas, oil, and water. So all these factors can play a crucial role if the well can be flowed again or not, because we know the hydrostatic head here is relevant to it's against the flow. Is it low or high? So when we try to open the well to the flowing, it's make a constraint to our well to be flowed again as natural flow. Okay. In low pressure wells, tubing head pressure can be deceptive. So don't depend on the well head pressure. Why? Let's check. So after the well is seized, we come to the surface, we come to the Christmas tree and check the upstream. Sometimes it's relevant high upstreams because the gas breakout accumulated, and we have high pressures, maybe because of the trapped pressure inside the trapped gas inside the Christmas tree, causing high pressure readings for the upstream. But the question is this uh, can tell us what is the PWF here? I don't think so. We need to have a look at our simulation. What tell us before the well is seized? So sometimes we have more gas, and then we have a very high tubing head pressure. So tell us, okay, we can flow the well with quite good position because we have a good pressure here at the wellhead, and this pressure tell us, okay, we have a good pressurized system inside the wellbore. So when we open the well, it's flowing with performance, good performance, without any issue regarding the well fluctuation again. So it's not fluctuated because we have enough pressure to support the flowing. But the question is that wellhead again, it's tell us what is exactly we have inside the wellbore? No, because we have many examples when we didn't have relevant historic data, we didn't check accurately or take the right decision of, okay, because we have like these pressures, we can open those wells, and then we have a relevant and stabilized flow afterwards, because we think those pressures it's enough to make the well flowing back again with more stable. So we lost some wells in the same day. We lost some wells after 2 to 3 days because those wells have not potential enough to flow again, because we didn't consider what is the wellbore condition, if there are any something related. If we just take like this simple idea of about the wellhead pressure, not taking any damaging corrosion, tubing issue, annulus issue, scale, etc. for wellbore problems. So if we just take like this simple idea, so it's not enough for low pressure wells. Tubing head pressure can be deceptive. So don't rely on like these pressures. You have to check before what the well was doing, Do you have any relevant data of from your simulators? What tells you regarding the performance before the well is seized? Okay, let's move forward. So what we can do, slowly depressurizing well won't work. Why? When we open, well, what we saw when we open slowly the well, we think, okay, because we have a good pressure inside, then it's enough to the well to be flowed. So the well it's not back again with a normal condition, because slowly depressurizing it's not work enough to support the flowing from bottom hole, because we have not enough support from the gas, or the gas is not dissolved inside the oil to make it flowing. The well is still loading, and we have unsuccessful of operation of putting the well online again. Okay, so what's the solution? Open the well fast. It's just like a Coke can. When you open it just fast, you have like this wonderful fall out from your can. So throw out the fluid like and shake Coke bottle. So open the well fast. Why? Let's check. So if velocity is important factor here, playing in unloading a well. So if we consider what is the size of inside diameter inside our wellbore, do we open both tubing annulus? Do we put the tubing only, annulus only? What is the size? So the larger diameter for our pipe means lower velocity, and lower velocity means we don't have a successful restarting wells, because we don't have the speed enough to remove put the flow again from the reservoir inside the wellbore to the surface. So we have to consider what is the criteria of the diameter. Do we have support pressure enough? Because we think those wells, it's we can unloading them, but the reality is not. So we have to consider the small diameter. What do you mean by small diameter? We have to put the wells as an on tubing only, and put the annulus pressure to help us to remove the fluid from tubing to the surface. So one of the successful process we found afterwards, after some tried to unloading the well and putting those wells again online, when we have pressure inside our annulus, and this pressure can remove and unloading the well and put the well online again with a natural flow without any problem, and the well is stable again, because this gas dissolved again, and pushing the oil to the surface, the liquid to the surface without any problem. So annulus pressure can help for that reason. Okay. Successful oil restart key points. Open tubing only. Keep annulus closed. Big choke, and be patient. Why? Sometimes it take time. So you need to be patient to have the right results. But what concerns us? So sometimes we have sanding issue, we have hydrates. We know the Joe Thompson effect when you have differential pressure and the temperatures, and you have like this choking back our flow. So we have and the process stability for if it's stable enough or not. So you have to that's why you have to be patient, and you have to consider like these things before restarting your wells. It depends on the reservoir condition, it depends on the type of the reservoir, it depends on the well type, it depends on the condition. Is it in summer, is it in winter? we have to consider many things before starting your wells. So we're taking the very simple idea of restarting our wells here. So we are not going deep, but you have to consider like these things. Okay, things we can do when the well doesn't restart. What we can do? Let's think about, uh, is it worth to go for another type? Yes, of course. So flashing. Flashing, we put some wells. If it's not flowing naturally, you put it on a certain header. There's a certain header for flashing wells inside the degassing. So you just put it here and connect to that header and to that train and flush the well. What is we need a spare train inside our degassing if it's available. So depressurize that train to make it available for that well to connect it to. Line up the well to the space train and header and open the well. That's it. So without any restriction, we have wonderful, nice flow afterwards, and then put the well back again to the normal position inside the degassing. Flowback, you can install the set of the flowback package inside in the field near to the wellbore and flare the well to the pit. So open the well to the pit and wait for stability of the well to be stable, and then when you have all the parameters in hand, you can see the well is flowing nice and smooth. And to lift. Why we do and to lift? To because we know sometimes we have a heavy viscous liquids inside. If we have any water cut inside the wellbore, then we have high hydrostatic pressure against our flow. Then we need to make it more light. So we pumping nitrogen inside our bowl to unloading the well and make the well flowing back again. So we need a cold tubing into nitrogen, I mean, and run in hole, circulate the nitrogen inside your bowl, and then we have a nice flow afterwards. So ESP, it's very simple idea. You have if the well is seized, you can run the ESP just with a normal condition, or you have to check if it's that work or not. And most of the time, it's the ESP like sucking the liquid to the surface and make the differential pressure between the reservoir and the PWF here. So there is a differential pressure between the wellbore and the reservoir. Then the well is flowing natural. I mean, with the ESP, the help of the ESP, without any problem. So it's make it easy to flow to the surface. But sometimes it's harder to operate. So why? Because it's sometimes you have to consider what is the pump condition, if you have any high hydrostatic pressure, if you have water cut, if you have gas breakthrough, you have to consider, is that worth to operate the well again without causing any damage to the ESP or not. So what is the well parameter in terms of the PVT before running the ESP and losing that ESP? And you know you need to install move a rig and remove that ESP and fix it again and put it again. So it costs money and time when you do something and calculated beforehand, calculation beforehand to operate the ESP. So you have to take the consideration of what is the ESP condition and what is the well condition before it's seized. Okay, swapping, another type of loading the well. So slick line, it's very simple, and swap equipment and run in hole and pull out, and then you have differential pressure inside the wellbore and the well flowing again. Gas lift, you can maybe if you have a gas lift, so you can inject the gas, make it more lighter, and then it's unloading the well and flowing the well to the surface through the tubing or annulus. So I think we just finished our webinar today. Hopefully, you have enjoyed this webinar, and if you have any question.
Thank you, Mr. Mohammed, for your informative presentation. So please let's see the questions in the chat book and or chat box and answer them, please.
Okay, okay, let's check. Mm. Oh, from Sarah, what do you mean the annulus pressure can help? You mean to increase the annulus pressure or change the fluid type? And the annulus, more clarification, please. No, we will not do anything uh, to the fluid inside the annulus. The well is seized. So when you can back again in your mind to the illustration when you have the tubing and annulus, it's in a stable condition. Let's say we didn't open the well till now to the surface. We didn't open to flow, so there is accumulated gas inside the annulus and tubing. We need, as I said, we need a small diameter to flow because velocity play a crucial role here to unload the well, so we can get benefit from this gas accumulated inside the annulus to help us pushing up the liquid from the tubing because we are closing the annulus, we open just the tubing, and then we have the velocity enough to flow the well to the surface. That's why I'm talking about the annulus pressure can help. We don't change any type of fluid. We didn't inject anything. If you know you can inject, you can do the end to lift if you would like to inject. If it's not successful, and but you have to consider what is the reading and what is the well history before doing so. With the single zone and low productivity index well in ESP wells, uh, Hijadindar, what is the best strategy to start the well? Because I am struggling with getting flow in that well due to gas lock. So you have gas lock, okay? And that due to gas lock for infertility, there is a high GOR. Good question. So, Didar, what you can do, you have ESP, but you have high GR. So, if the ESP doesn't have any gas separator, maybe there's a risk of losing that ESP because it will take a high ampere to run that. Well, so what I we do, what I recommend to run and stop the SP and see gradually if the well is flowing because you cannot or maybe it depend on the readings you have for your wells and you know it's a low PI well, then you of course we have struggling to put the well in normal condition, but because there's a ESP inside, so you have to consider what is the size of the ESP, what is can be around, what is the fluid properties before doing so. But in general, you can run and close for a short time. Then you have to run for long time before put the well in stable condition on flow. So why I'm telling that you don't need to you don't want to lose the ESP because if the gas look inside. So it's like pressurizing, depressurizing the well and without losing the ESP. Thanks, Mr. Al-Jawhar. Thank you, Mazen. Uh, okay. I think, Doctor, this is all the questions.
Yes, Mr. Jawhar, I think we can close our today's webinar. So, at the end of today's webinar on restarting oil wells, We would like to extend our sincere thanks for your participation. I mean, our participants today. It was a pleasure having you with us, and we look forward to welcoming you to future events hosted by Enkido Training. Also, a special thank to Mr. Mohammed Al-Jawhar for his valuable and insightful presentation. Your contribution is greatly appreciated by Enkido Training Team. Have a nice time and goodbye.
Goodbye. Thank you again for you and for Enkidu training. Thank you.
Thank you. Bye bye.